Hello CS112, today I'll be going over a quick solution to Lab 12, I think, that has to do with everybody's favorite subject, which is recursion. I will be using Python Visualizer, which is apparently similar to Thani's debugging mode, although I can't attest to that because I've never used Thani. But the reason I'm using this in my solution is because this is how I learned recursion when I was in 112, because I had no idea what was happening. I still might not know, who knows. But yeah, it's nothing you have to download. You just Google Python Visualizer. That is a typo right there. But you just click on the Python tutor link and it will take you to a web page that looks like this. And this will help you visualize the stack frame so you can understand what is happening with recursion. So I will be solving two different questions, not just the one in lab. So the one in lab, it wanted you to count the number of even elements in a list. I'm going to do that, as well as I'm going to recursively build a list of only the even elements in that list. So I'm going to create one that, let's say, I'm just going to wrap in the print statement already. I'm going to create a function called count evens, which is similar to the one in lab, where if we're given a list of 1, 2, 3, 4, 5, and 6, I would count the amount of even elements within that list and just return an integer. So this is recursively counting something. I'm going to show you how to do this, as well as create another recursive question called evens list, let's call it, where you're going to be given, let's say, the same exact list, except this time you would be returning an actual list with only the even elements in it. So that'd be just 2, 4, and 6. So I'm going to show you how to recursively count something as well as recursively build a list. This is going to be important for programming assignment, maybe programming assignment 7, you have to recursively build a list. I don't know. That's just me speculating. Okay, so before we start with count evens, I will say that whenever you're doing recursion, do not use a for loop. You can use a for loop with recursion, but that's like an advanced level of recursion that you guys should just never touch. If you guys try doing it now, you'll likely get infinite recursion where you'll like exceed the stack frame, which, I mean, you don't want to do that. So just don't use a for loop with recursion for now. So one of the things I will go over real quick is I was actually explaining this to a student earlier during an office hour, but I will delete this real quick. So it's the difference between iterating through a list using a for loop versus recursively, kind of the algorithm behind it. So if you're iterating with a for loop, we know that we're going to start with the first element here, then we're going to shift over, we're going to look at the second, shift over, look at the third, so on and so forth. No idea what happened there, a little glitch or something. We're just going to keep shifting over, looking at the next element. Well, if we want to recursively parse a list, we're going to need to work completely differently. So we're going to start at this first element here, but then after we've looked at this first element, we're going to just get rid of it and then move the next element to be the first element here. So we're still looking at the first element, but now our first element is this 2. Once we're done looking at that 2, we get rid of it, move the 3, so on and so forth. Now, luckily for us in Python, the whole moving notion is going to happen automatically, so we don't have to, manually shift everything over in our list. So we're just going to continuously check the first index, or the 0th index, or the first element, while removing it or slicing off the first elements. So the first function we're going to create is called count evens, and I'm going to pass through a list. Let's call it x's. And now this is how you're going to recursively count in Python. So as I just described, the algorithm for iterating through a list is literally destroying the list by removing one element at a time. We know that we're done with our recursion when the length of this list is 0. So I'm just going to create a little comment here that says base cases, because you can have multiple base cases as well as multiple recursive cases. So I'm just going to put those in parentheses. For this specific one, there's only one base case. It's just when the length of x's equals 0. So if the length of x's is equal to 0, I'm going to return 0. So now it is important that your return value here in your base case is the same data type as what you are returning for this function in general, or else you're going to get conflicting data types and you'll get one of those annoying errors where, for instance, for this question here, if I was to just return an empty list, it would end up hitting you with like unsupported operands between list and integer. So just make sure that your base case is returning the same type as what you were planning to return at the end. Lastly are our recursive cases, which I'm just going to put in an else block here to distinctly separate it. You don't necessarily need to do that, but I'm just going to do it anyways. So now for our recursive cases, we actually do have two recursive cases because we need to handle the two cases, right? If it is or isn't even. So if not even, I'll just do it in that order, and if even. So if it's not even, what are we going to do? We're going to simply slice off this first element and pass in this portion of the list so we can continuously check the very first elements and move through. However, if it is even, so let's say after the first iteration here, we pass through this next list, so our next recursive call will look like this with a list like this. When we check that first element is even, it's going to go into here, and we want to count that. Now, how to count? Well, the plain vanilla, if not even, so if x is at the 0th index, modulus, I'm not sure what's happening here, modulus 2 does not equal 0. That's how you check if something is not even. If you want to check those even, you just make this equals. So if that first element is not equal, or modulus 2 is not equal to 0, that means it's odd. So we're simply just going to return a function called count evens with the first element sliced off. So count evens from 1 to the end. This just means start from index 1 and go all the way to the end of this list. So it will start from index 1, go all the way into the end of the list. So that's exactly what we want to do, right? Going back here, we are getting rid of that first element, and our next element is becoming that first one. And moving on here, this is if it is even. So if it is even, I'm just going to make that an else block. I'm going to be using this exact same return statement, except we want to count, right? And in order to count, we simply do +1. Now, that might look too simple or make absolutely no sense, but this is where Python Visualizer is going to come in handy and actually help us understand what's going on by stepping through our code. Now, I am really quickly just going to run this to make sure I didn't make any typos or anything like that. So when I click last, I do have a typo. All right, that's not even a test case for this one, my bad. So that's not even a test case for this one, that's for the next problem. So when I click last here, we get the expected output. All right, so we know it works. So now we are going to be looking at that word I used before called stack frame, which is what helped me learn what recursion is. So to step through this code, obviously Python's going to start by reading the first line of code, which is just the function definition. Then it's not actually going to enter here until it is called. So it's going to go down here, see the function call, come back, and then enter. So once we have done that, it's going to check our base case. Does the length of this list equal 0? It obviously does not, so it's going to enter this else block here. And it's going to check if the first element, x is 0, which is 1, does modulus 2 does not equal 0. Since it's odd, this is going to be true, so it's just going to return count evens with the first element sliced off. So something I will mention right now is this is our stack frame. Every single time we make a call to count evens, it will just be added to the stack frame here. So for instance, when I click next, it's now going to call the function again. We have another function call. See, another function call was added to the stack frame, but now we've sliced off that first element, which is what we wanted to do. And then as we go here, if the length of x is, so you check the base case, so on and so forth. This time it is even, so it's going to enter here, and this time we're going to return count evens with this +1. That +1 is key. That's literally how we're counting. This is what's doing all the work for us. But as we go on, it's just going to continuously slice off the first element until we get an empty list. When we get an empty list, the length of this is 0, so it is going to enter our base case. It already entered our base case, my bad. Wait, where am I right now? Okay, boom, boom. Okay, so enters our base case right around here. Now that we have an empty list, as soon as we hit, when we have a bunch of recursive calls like this in a large stack frame, as soon as it hits a return statement that's not a recursive call, so in this case it's return 0, it's going to start popping everything off, and it's going to remember each and every single one of the return values. So it's going to be this return value plus this return value plus 1 plus this return value, so on and so forth, which will be demonstrated here. So when I click next, as you can see, the return value is 0 because I just returned 0. I'm going to click next again. Our return value is 1. So if we go back here, what this is essentially saying is we want to add the previous function call, the previous recursive call, plus 1 to the previous, recursive call plus nothing if that's the specific one we're at, so on and so forth. So right now the return value is 0. When we click next, the return value is now 1. When we click next, the return value is still 1, so that was 0 plus 1 plus 0 is 1. When we click next, now we're at 2 because this was our return here. This was the return value associated with this call stack, this stack frame here. And then when I click next, it's still 0 because this return call did not have a plus 1 with it. This one did, so it's going to get to 3, so on and so forth. So this stack right here is what taught me recursion. It kind of works in reverse, so to speak. So as you can see, it did start with the 6 as our first, and then 4, then 3 to actually increment that. So the way I learned recursion is I literally copy and paste recursive code into Python Visualizer, or you can even do this in Thonny's debugging apparently, and see the stack frame build up and how it builds up and then decomposes, combining the return values of every single call to the function. So now for the next one, before I do that though, how can I, rather than just counting them, how can I actually find the sum of all the evens? Well, rather than saying plus 1, I would just say plus x is 0. So in this case, it would be 2 plus 4 plus 6, which is 12, according to math, I think. So I'd literally just change that one line. Rather than plus 1, I'd actually add the element itself. That's just a quick little thing I'll add. But now we're going to go to how to recursively build a list, which I don't know, but it sounds like it might be useful for something. Maybe, maybe not. I could just be saying things. This is how to recursively build a list. Now, since I did just mention that it pops off in reverse order, our list will actually not be 2, 4, 6. It will be 6, 4, 2. So I'm just going to change that because the list 2, 4, 6, and 6, 4, 2 are not the same in Python because lists are ordered. So this is what we would get as our return. Now, something I will say, which a lot of people just didn't know, which I thought, you guys were taught this in class, but you guys just probably forgot, is if you have a list 1, 2, and you have another list, let's say 3, 4, if you wanted to combine them, so have a list 1, 2, 3, 4, you wouldn't do this list dot append this list, because you would end up getting this if you did that. You would append that entire thing. You'd have a sublist in there. So the naive approach would be to iterate through this list and append each of the elements in here, but in Python, you can simply add the lists together and you would get the list 1, 2, 3, 4. So this is the logic we're going to be using to build our list here. So yes, we are going to be using essentially the same algorithm. I can leave this code as is, so I'm not going to just go through again and explain the same algorithm. I'm just going to be changing the function name to evens list because I don't want to get that error, and I'm going to be changing what I am adding here. So what do I want to add here? Since I know that if I was to add a list to another list with a simple plus, I can build a list dynamically. So rather than just say this, because we know that this will return just 6 plus 4 plus 2, I'm going to return the list version of that. So rather than this being every function call, rather than it just being the integer 6, it's going to be a list with the integer 6 as an element. So it's going to end up being 6 plus 4 plus 2, which is going to equal this based on the logic down here, which is how you recursively build a list in Python. So now I was about to run it, but I'm sure you guys are screaming at me, if you're watching this, that I need to change this data type to be a list because I'm not a noob. And we need to make our base case return the same data type as what we're expecting as our return. So I'm trying to see if I don't think I made mistakes. Let's just visualize it. Okay, so apparently I have made a mistake because it's only going twice. Evens list. Ah, dang. I thought I did it, but apparently I did not. Evens list here. All right. Okay, that looks about right. It's 36 iterations, and yes, we're getting 642. Again, it's in reverse order because the stack builds and then it starts popping in reverse order with those return values adding in that reverse order. So when we step through this again, So when we step through this again, what's happening here? So wait, next. I have no idea why it's just skipping to the ends when I do this. So wait, next. It calls that function. And it just goes to the end. I have absolutely no idea why it's doing that, so I'm just going to run it again. And hopefully it will not bug out on me like that. Okay, so as you can see, the same algorithm as before. We're just going to be iterating through the list recursively by constantly looking at the very front of the list and then removing that same index, so everything else will shift automatically for us. And as we get to the length of list equals 0, which is here, it's now going to start popping off. And when it pops off, it's going to remember each of the associative return values here. So in this case, 6 will have a return value because it's even. And what is that return value? The return value of our base case is an empty list, but with 6, it's going to take that empty list and add it to a list of 6. So it's going to, I'm not going to edit this code, but it's going to just take an empty bracket. So you can imagine this just being an empty bracket and then this being a list of 6. It's going to add those together, it'll just be a list of 6. So when we go here, we have that list of 6. And then when we get to something like 4, it is going to add 6 and 4 together. And then when we get to 2, it's going to add that together as well to dynamically build the list recursively. So this is super important. I'll just say it, this is super important. I forgot which one it was, but one of these this one you're building. I just took out an earbud. This one you are recursively going to want to build a list. At least that's one way of doing it. I mean, I think it might be the only way, but I don't know. You guys are smart. But this is super important, how to recursively build a list, how to recursively count something, recursively find the sum. I've done all of those in this video. And also getting comfortable with actually iterating recursively versus just using a for loop, because you guys should not use a for loop in this recursion. So if you guys have any questions, do let us know.